Kanmon Strait divides the island of Kyushu from Honshu, Japan's main island. Linking these islands was the job of the world's first under-ocean tunnel, completed in 1944. Lessons learned here let Japan undertake the daunting task of a tunnel to link Honshu with the northern island, Hokkaido. The trigger was the loss of a ferry boat with over 1,000 lives in 1954. Construction of the Seikan Tunnel began in 1971. The Seikan Tunnel was finished in 1988. Honshu and Hokkaido were joined by the longest tunnel in the world. Technology developed for the Kanmon and Seikan tunnels played a major role in building another tunnel. Half a world away, the Eurotunnel under the English Channel. This is the breakthrough, the final moment. Until this moment, Britain, the island, was odd man out in Europe. Now, symbolically at least, that special status has come to an end, thanks in part to this remarkable machine. The Eurotunnel now links Britain to the continent of Europe. Till now, travelers' options were limited to plane, boat, or hovercraft. The Channel, as it's called, was born of the conjunction of political imagination and modern engineering. It's certain to become a major link in the infrastructure of a new, united Europe. The first test run of a train from France to England was made in June 1993. The tunnel runs below the ocean floor of the English Channel for 38 kilometers, though its overall length is nearer 50. It's strictly for railways, and when it's in full service will run 10 trains every hour. The car trains will carry trucks up to the size of 40 tons. The construction of the Eurotunnel took a mere 3 years. This was in part due to favorable ground conditions, and in part to technology. The dream of a tunnel under the English Channel has been around for at least a couple of hundred years. In 1876, Queen Victoria and Napoleon III agreed to make it happen. Drilling was done on both sides of the channel. The remains of this short-lived enterprise can still be seen near Folkestone. Techniques used then for drilling through chalk were primitive precursors of the ones we use today. The machines themselves were steam-powered prototypes of the ones used in the 1990s to excavate the channel. Politics halted this project after a brief 2 kilometers, and the dream lay dormant for another 100 years. The modern world is very different. In the 1980s, Japanese machines played their part in unifying Europe. Eleven of these tunneling machines were used to dig the Eurotunnel. France and Britain mobilized their engineering power. Vertical pits were dug on both sides of the channel. From the bottom of the pits, the tunnel machines began to dig horizontally. The rotating cutter is at the front end of a cylinder of steel which encases and protects the whole machine. Behind the cutter is an apparatus which assembles the concrete lining of the tunnel while excavation proceeds. When a ring of concrete is complete, a series of hydraulic jacks push against its rim, and the whole machine advances. It's called a shield machine. It builds as it drills, and trails the finishing lining and its own support surfaces behind it. This is the shield construction method at its best. The chief problem encountered by engineers building undersea tunnels is water seepage. In the case of the channel, the geology was benign. A stratum of blue chalk running 40 meters below the channel floor resists water penetration. But the layer is only 20 to 30 meters thick, so careful subterranean navigation was essential. The shield machine is not suited for drilling in complex or unstable strata, but it is ideal for blue chalk. Sometimes the machine dug 50 meters a day, 3 times faster than expected.